This is our solar system here. These are 6 200-watt panels, and they provide, I've seen on the Outback FM80 charge controller, up to 76 amps coming off these batteries at around 13.2 volts. Hello. Thanks for watching, and we would like to discuss the power system for the trailer. We're using lithium-ion batteries, but we have previously used lead acid, and we've now changed. The benefits, I'd like to talk about the benefits of lithium-ion, or shall I say the problems with the lead acids. Anyway, the main benefit of a lithium-ion battery is if you have a certain capacity, then you can use 100% of that capacity. Unlike lead acids, where no matter what the capacity, the amount of allowable, usable power is only 50% of that, or until it reaches around the 12-volt mark. Why can't you go any lower than that? It becomes an issue of the plates sulfating up. And sulfate is like an insulator. It coats the plates, and then they become less and less usable as time goes on. Another major benefit of the lithiums is the high efficiency of the charge and discharge curves. They're almost 100%. They're just under 100%. There's absolutely no heat losses in lithium batteries. And if you put in so many ampere hours, you're going to get that same amount back. Whereas the lead acid batteries, they're extremely lossy, especially under high load conditions. In fact, you may lose more than 50% of your usable, available power if you're drawing high loads. Okay. Under the bed, we've got all our liquids, fluids, and the electrical system. As we see here, the far tank is the black water. The next tank closer to us is the gray water. And then we have the two freshwater tanks. These tanks are all 50 gallons apiece. They're all identical. And all the connections come in from the top. With the tanks, we also have a level measuring system, which is a non-contact, which is this little yellow box at the wall. And you see the yellow cables here. These all go to the various level measuring transducers. For example, here. With the electrical system, here is our sine wave inverter, a pure 60 hertz pure sine wave. Next we have the lithium-ion battery controller. Get it from here. This is the lithium-ion battery controller here. Basically, there's a computer which measures temperature, voltage, and does balancing of the cells. The computer is located on the opposite side And with it, it has connections for the disconnect solenoids, the data cable which speaks to all the bridges and takes measurements. On the other side, we have the two disconnect solenoids. One is for overcharge and one is for over discharge. And they will disengage if certain parameters are not met. Over here we have the solar charge controller. This is our configurable charge controller. And set. And then next to that we have the battery charger. Say we have a few rain days and there is no solar energy and the battery goes down. We can bring it back up through this charger using the generator or outside power.
Stopping.
Yeah. This yellow box is a power transfer relay. There's two modes. One is the solar power through the inverter, and the second mode is the generator or outside power. This will switch over. Okay, you going?
Yeah.
External power comes in through the top, and this will energize the relay coil and switch it over to external power. If you disconnect this, the relay will fall back over onto battery power. I just want to show you a drawing of what's inside that box. The shadows are no good.
No, it's fine.
Okay. Here we have the outside power or the generator, and when that is powered up, it'll energize the coil and make these switches go into the lower position. And then you have the straight through outside power coming to those contacts when the armature is pulled down. So now you're seeing outside power at the output. This is distributed to all the loads in the trailer. Once the generator switches off, the relay coil is de-energized and it will go back to the shelf position of the armature, which means that the inverter output is now the active agent powering the trailer. The Elite Power Solution batteries were originally intended for electric cars, so they have a very high storage density, and I highly recommend these batteries. We've been using them for 3 years now, and they're still as good as the day one. So the various components of the power system for the trailer are all shown in this drawing here. We'll start going through it step by step. Here we have 6 monocrystalline solar panels, and we have 3 in series paralleled to another 3 in series. The reason for this, we have to explain open circuit voltage. The charge controller has a certain open circuit voltage maximum limit, and if you exceed that, the unit is essentially destroyed. So you have to stay below that value. For the Outback FM80, the open circuit voltage is 150 volts. So in this case here, each of these panels is 42 volts. So we've got under 150 volts by quite a bit. So that gives us a little bit of a margin of error. At this point, I'd like to discuss the wire thicknesses required for the input circuit and compare it to the wire thicknesses of the output circuit. As you know, or might know, power in watts is equal to volts times amps. The voltage drop across a wire, is equal to amps times the resistance. Resistance is opposition to current flow. Now, if you can have, seeing that power is volts times amps, if you've got a high voltage, 120 volts DC, you're going to have a small current. If you've got a low voltage and the same power, in this case, you're going to have 10 times the amount of current. Because as current increases, the voltage drop across the wire increases. When we go into heavy loads or heavy currents, we must use thick gauge wire. In this case, you're talking basically welding cable, at least a 0 gauge. When we're up to the 120 volt mark, the solar panel input side, the voltage is 10 times higher, therefore the current is 10 times less, and we can get by on thinner wire. In this case, the manufacturer of the panels has already specified 12 gauge, so that's what we use. One last thing with these panels, they need to be mounted on the roof of the vehicle in such a manner that there's absolutely no shadows falling on the cells. A small shadow can reduce the power out by a significant amount, a lot, half, perhaps half. Getting onto the solar charger, this is the FM80 Outback, and that's the one we're using here. Continuing on, we have the battery. In our case, we're using a lithium-ion battery. In the lithium-ion battery, the circuit is a little bit more involved than with a lead acid. You have a charge solenoid and a load solenoid. You have a computer or a battery management system which monitors each cell with a bridge going across the terminals, and that's monitoring the voltage, the temperature, the balancing of the cells, whether they need to be balanced, and it will balance at the correct point in time. If there's any overcharging or over-discharging of the cells, or you're outside of the temperature range, these solenoids will be disconnected from the battery management system, and that will save the lithium-ion batteries. Lithium-ion batteries are unforgiving for overcharge and over-discharge. It causes permanent damage, and you will never be able to recover. Now, in the load circuit, there's also 12 volts DC. The pump, the macerator pump, the water pump, some of the lighting run off the 12 volt circuit. And then we have the power inverter. Again, we're using super heavy gauge wire. because we've only got 12 volts to play with. With 12 volts, we're dealing with high currents. When you have high currents, the voltage drop becomes very high as well. For the inverter, the most important thing that I would recommend is that you make sure you have a pure sine wave inverter. Some electronics will not work on modified sine wave. In the final 115 volts output to the loads, we have our own custom built, custom designed power transfer relay. If it's a rainy day and we don't have solar energy available, we might consider using a generator, such as a Honda EU3000IS, which is electric start, and then this will switch the contacts of the power transfer relay and supply all the loads. If the generator isn't running, it's all taken over by the solar system. One more thing we use when we have rainy days and the batteries go low, we use a 60 amp charger. Basically, any constant currents at 60 amps will work with a lithium-ion battery, provided that there's a high voltage trip. And in this case, it's set to 14.10 volts. Once it reaches 14.10 volts, the 60 amp charger is taken off the batteries. We don't want the voltage to go any higher than that. Okay. So once again, I want to look at the battery itself. This is our lithium battery. Here's all the battery cells. In this case, we're using 4 cells. There's a battery management system, and the battery management system has a data way which communicates to each of the 4 bridges going across the battery terminals. What it does is it measures the voltage of each cell, it measures the temperature, and it also performs balancing of the cells, so that all the voltages of the cells are the same. That's what it tries to achieve. Now, the battery management system safeguards and protects the batteries from overcharge and over-discharge. It does this by using 2 solenoids. Here's a charge solenoid, and here's a load solenoid. And if either one of those 2 are out of spec, this coil will be shut off and that particular part of the circuit will be disconnected. Therefore, the load is isolated from the source of the power. So when everything is working fine, both of these solenoids will be engaged, and you will be able to charge the batteries. You will be able to discharge from the batteries, and you will be able to discharge over the batteries straight from the solar panels and onto the loads. In our air conditioning setup, we have the ability to run the air conditioner straight off the solar panels if the batteries are full. If the batteries aren't full, some power will go into the batteries and some power will be taken from the inverter and distributed to the loads. Okay. These solar panels will produce over 1,000 watts. And And some of the loads that we put on it are the air conditioner, which by the way runs in a proportional band. It doesn't switch on and off like your conventional air conditioner. It speeds up and slows down, but it runs continuous. Other loads are fridge, freezer, TV, computers, and during the daytime, if it's a nice sunny day, you can power all that from the solar panels and still charge batteries. Thanks for watching, folks. If you liked what you saw, please subscribe. And if you have any questions, feel free to shoot us an email. Bye for now.